guys, just make sure everybody's on the right track. We're going to do the first couple steps together, and then you'll keep going. What is the claim? Sweet. Right? The mean bigger than what it used to be. Right? That's what her claim is. Blah, blah, blah. So, which one is that going to be? It's got to be H1 because it don't have no equal sign. That's right. Just to be completely grammatically correct. So it's got to be here. Your claim is always going to be one of these two, and it just really all depends on, does it have an equal sign? So what's the opposite of that? And again, the book always has an equal sign there, so if you want to always put an equal sign there, feel free. That's just a different way of looking at it. The most important thing is this guy, because do you guys remember, if I ask you this, who can tell me, what does this guy do for me a little bit later? I mean, what can I tell right now, according to this dude, that is actually asked in this question, part A? I love that question. It's like, what the hell do you want from me? Is it a one or a two-tailed test? How do you know? Because of what this dude says, always. So that's why this guy has an equal sign, because this guy is okay with it being the middle. This guy is the one that says, no, it's greater, it's different. So that's the one that's the extreme. It's not okay with it being in the middle. Does that make sense as to why this can't have an equal sign then? This statement has got to be the one that sets up my rejection region. It's got to say which direction do I want my sample to show up in. So I want this to be greater than that. One-tailed test up there. I want my sample to show up way the hell up there. Kick ass. And I said this already, but you tell me why. Z or T? Zort? Yeah, why Z? Because Jeff said so. No, what?
Population standard deviation.
Yeah, so sigma known. And N is 264, just a little bit bigger than 30. Cool. I like it. Good. So if you got that so far, you're on the right track. Keep going.
Oh, wait, did you have to... Oh, you just plugged it in.
Yeah, I always close it. what 2.326 would round to.
Oh.
Yeah. So if you have two decimal places, I know you look there. If you have three, I know you look at the T-chart.
Oh.
Yeah, okay. It does. Guys, let's see how the next step worked. So one-tailed test, which means the whole alpha gets put in that one tail. So you look at the t-chart again, because of course where do z-scores live on the t-chart? Way at the bottom. Cool. So we go all the way to the bottom of the t-chart. These are all z-scores down there. All right. So you want to look at one tail. 0.01. So that should be the, which column? Second column in. If you go all the way to the bottom, you get 2.326. Now, if you look at the Z chart, just to remind you guys, if I want 1% up there, what's below it? 99. So I can look at 0.99. So which one of these is closer to 0.99? This guy. All right, so let's see what he is. He is 0.03, whatever he is. And then over here he is 2.33. Shit! And that's exactly what 2.326 would round to. So depending on which chart you look at, I personally don't care because they're both valid ways to do it. This is just a little more precise. Which goes to somebody's question the other day. What if my Z star was exactly this score? Well, then you want to be more precise on both of them. You want to round less. You want to take it out more decimal places to see which side it fell on. Does that make sense? Yes?
Wait, but like going into the problem, I thought you said we like had
To do what?
I thought you said we had to use the score chart.
Never. I said if I ask you for an alpha that's not on your t-score chart, then you have to use the z-score chart. So if I say alpha of 0.03, is that on your t-score chart? Then you'd have to use, then you have to look at 0.97, right? You have to get close to 0.97. You guys with me? The t-score chart's awesome. Why is it so much more brief? Because it has a lot less detail in it. Z-score chart's got stupid amounts of detail. T-score chart, very little. So that's why there's a lot of situations where you can't even use it. Okay, cool. And not really, because we normally use 95%, 98%, 99%. We normally use those kind of things, so the T-chart actually gets used a decent amount. All right, so what the hell does this mean? If Z star, what can we do? Yes? Reject the hoe? Or HO if you want to be careful. If you don't want to be as, crude as Jeff. And support the high. I like it. Right. Does that now step outside of all the technical language and all this stuff? If my sample is further away than this from what this thinks the middle is, then this is probably not the middle. That's why I can reject this. If my sample shows up way up here, the probability that that would happen normally is 1%, right? So what's more likely? What's more likely is that's not the real middle, that the real middle is higher, that our claim looks to be true. I reject this. I support this. If I don't make it there, then I fail to do both of those things. Yeah?
Does it matter in that statement, like which one we put first, reject or support?
No.
Okay.
Yeah, because they're both basically saying the same thing from two different ways.
Okay.
Right? If I said you're half as old as I am, if I said I'm twice as old as you are, that's saying the same damn thing, two different directions. Yeah. All right. So try part D if you haven't done that yet. It sucks that that statement's probably true. If you wait long enough, you get old. That's what happens.
So we have to change that. It's not this one. 1.645. Just minor adjustment.
Bless you. Try to see if you can't find that p-value if you haven't tried that. All right, so let's see. Somebody help me out. What's the new standard deviation here?
0.175.
0.175? Yes, ma'am.
So we don't only do this dividing by the square root of n when we have only the x.
You always do that. These symbols, I know that's population, that's sample. What do they have in common? What do they both measure? For what? Individuals. So I have to, I don't care which one I have to change it because now I'm talking about a group of size 260. I want to compare all the groups of size 264 and see where mine fell. It should fall here if that really is the middle. If mine falls there, that's evidence that no, it's not the middle. Is that cool? Does that help quell that? If you have S, you don't go, I don't have to do that. Yes, you do. That's for individuals. You got to make it the one for groups. All right. The Z-score formula never changes. Ever. You guys don't believe me? I don't care. Because I know it's true. It's always my data point. What's my data? 25.19. Minus whatever the mean is accepted to be, minus the middle, whatever the middle is, and the middle will be accepted to be this guy. We say, okay, assuming you're right, 24.81. Divided by standard deviation, 1.175. What do you guys get?
2.17.
2.17? So two things right off of that. Immediately, what can I tell? Yeah, did we? Yeah, oh shit, we failed. We suck. Did we make it as far as we were supposed to? No, we only made it there. Stupid us. No, that's fine. So the language of fail or not just means, is there enough evidence to say HO is wrong? Sometimes you don't want the null to be wrong. So fail is a good thing. Oh, thank God we failed. Right? Not a sentence you normally say. But I don't know which one we hope to be true. But we didn't make it. So we didn't. So how do I... before I get too far. So right here we can say fail to reject the null. Fail to support the high. So my sample was not far enough away from the middle to what the middle is supposed to be to say that the middle is in the wrong place. I can't say it's in the wrong place. It didn't get far enough away to say that at this level of significance. Is that cool? So that's why we fail to reject him. We can't say he's wrong. We fail to support him. We can't say he's right. It's because we didn't make it far enough away to say that. So what would my conclusion be? Did we find evidence? No, we failed. All right, so it seems to be the theme right now. Yes, Jeff, we know. We have not found sufficient evidence to do what? What's my claim? Yeah, which one's my claim? This is my claim, so I want to use this language. I mean, do you guys see how that step, don't make that step more than it is. My claim is H1, I use a language for H1. If my claim is HO, I use a language for HO. So I'm going to say we have not found sufficient evidence to support the claim that what? That the mean what? The mean age of first pregnancy, right? First birth. The mean age of first baby or birth or however you want to say it has increased. We can't support that, right? We have not found sufficient evidence to support the claim that the mean age of first birth has increased. We can't support that. Yes, ma'am.
Are we going to find the p-value?
Yes, we will. I forgot. So how do we find that p-value? What's our z-score that we calculated? What's the one that we calculated? 2.17. So can you find the area in this guy's tail? That's the p-value. That's it. See, it's nothing magic. It's nothing crazy. Alpha is the area in the tail of this dude. The p-value is the area in the tail of my dude. So if you look up 2.17, do 1 minus that, what do you get? It's 0.9850, right? And 1 minus that? 0.015. Cool. So about 1.5%. So my p-value is 0.015. It's not a bad p-value, is it? It's not bad. But how stringent was our test? Our test said it had to be below 1% chance. We only got to 1.5% chance. It wasn't small enough. Now stay with me now. It's much easier to see visually the z-score. I can tell I failed because I didn't make it far enough. I had to make it this far, I only made it that far. The p-value is a little bit weirder. Here's alpha. If I did succeed, where would my sample have been?
Yeah.
It would have been up here. Its tail, would it be bigger or smaller than this tail? If I was here, my tail, would it be bigger or smaller than that? Smaller, right? Here's. If I'm here, there's my tail, a little tiny thing. And if that guy, ooh, big ass. All right, so I would have a smaller ass than that guy, right? You guys with me? This is weird. This is kind of the reverse of what you think. So in order to, where have we got? Here, if the p-value is less than alpha, we reject the null. That's a whole other way to look at this. Support the high. The really nice thing is, no matter which way you look at it, they agree. It's always the same.
That's like double check.
Sure. And that's also in case they only give you a p-value, you don't have a z-score, then you have to use it this way, right? Yeah. All right. Which, of course, most journal articles just give us the p-value. Yes, sir.
How do you get the p-value?
Look up 2.17. That was our score, right? And get the area in this tail. So when you look it up, you're going to get the area down here. I don't want that. I want the area in its tail. That's it. That's it. Don't make the p-value some magical thing. That's it. All right. There's one last question on there we haven't done yet, right? Pay attention. What else do I ask about? Yeah, if alpha would have been 0.05, would our p-value have been smaller than that? Is our p-value smaller than this? Is the p-value smaller than this? Yes, then we would have rejected. We would have found evidence. Let's look at that a slightly different way. If alpha was 0.05, what would the z-score have been? Yeah, 1.645. Z critical would have been 1.645. Would we have made it far enough away? We made it to 2.17. Did we make it far enough away? Yes. So the level of significance can change your answer. So in real life, if making a mistake, if not rejecting it means people will die, I will probably set it so that I will more often accept it. So I'll probably set the p-value, I'll probably set the alpha to be down here. So if I'm at a nuclear power plant and I want to set my alarms, I'm probably going to set the condition that they go off to be down here. I don't want to wait till way up here. I want to say if the temperature is this much above what it's supposed to be, I'm going to blare an alarm. That's my alpha. I'll say this again. If my making a mistake about the results of a test means that horrendous things will happen, people will die, right? My nuclear power plant will explode, Homer Simpson and his donuts go up, horrible. Then I want to set that condition down here. I want to make it easier to pass that test so that my alarm will turn on the minute I'm above there, my alarm turns on. So then it's an annoyance, not a death of everybody in the immediate area, right? Oh, there's the alarm. But if we set it way the hell up here and the alarm goes off, we're like, we're all dead. Shit, we should have set it up that high. You know, it's like the alarm only goes off to tell you, oh yeah, you're going to die now. So that's why alpha can change. And that's why alpha is different for different people. So like the insurance company, if I wanted to prove to the insurance company that because a fire department set up a place near my house, my fire insurance rate should go down. I think I gave this example before, but it's a beautiful example. They're going to set the level of proof, and they're probably going to set it to be pretty high, right? They're probably going to, and what that means is they're going to make alpha small. They're going to say your evidence has to be up here. So if we get there, no, too bad, your insurance rates stay the same. You guys understand? A little bit. What I'm trying to get to you is that alpha level can totally change based on your perspective and based on the situation. That's why journal articles only talk about p-values, because then you have your own alpha. So if we reported this p-value, somebody could say, oh, shit, that's good. They found evidence. If they had their own and personal alpha was 0.05, they'd say, wow, that's pretty good evidence. If it was these people, no, you have found nothing. Do you guys understand? That's why journal articles only report p-values, because where's the alpha? It's for we all have our own alpha, right? Right now you're like, I have my own alpha. Yes, if you were in an industry or something that's affected by the outcomes of that journal article, then you do have your own alpha. You will interpret results differently. Okay. P of 0.001, nobody's alpha is that small, basically. That's like, oh shit. But when you get to 0.015 or even 0.01, then people can disagree. Totally. And that's fine. There's nothing wrong with that. And that's another example of statistics going, I can't always have an exact answer for everybody that works. It's going to be different for everybody that looks at it. All right. So what I want to do now is one more example with where you can use z-scores, but the reason you can use z-scores is because this is a test for a percentage. So I've got the formulas down here. All the steps are exactly the same. But remember this. Remind me, who remembers the formula for the confidence interval for a percentage? I'll start it off. P hat. Plus or minus, yes. Z is in there, good.
Square root, P hat, Q hat, over N.
Good. Now, here's something interesting. When I want to make a z-score for a percentage, so I'm not going to find an x bar, I'm going to find a p hat. I'm going to find a sample proportion. Are you guys with me? So there's going to be a p hat that I get. There's going to be a p, which represents the population percentage. Right? And this piece, I said this earlier, but I don't know if you guys remember, that piece is basically representing the what? What normally goes there? What goes there? What's the formula for the mean? X. So you get x bar, and what goes with it? Sigma. So what's over there? So this is the standard deviation, right?
Right.
So this is effectively the standard deviation. So let's see if you can see why this makes sense. Z-score formula, let me remind you the weird-ass thing I believe, because it's true, Z-score formula never changes. So what's the Z-score formula for this? My data minus the accepted middle divided by the standard deviation for that. Now notice what's different there. Yeah, I took their hats away, poor little dudes. Why is that? Because when I make a confidence interval, do I know P and Q? Do I know them? What's the whole point of a confidence interval? What do you do to create a confidence interval? Why do we create a confidence interval? Why do we do it? Because you said to, Jeff, and I want to pass this class. So I thought I should probably do that. Okay? In the real world, why do we create that? We've seen people in the real world do it. Not just people in classes. They weren't in class. They did it. Shit. There must be a reason. Because they don't know what? The true mean or the true percentage. So, of course, they get a sample mean or a sample percentage. And then they say, well, I'm this sure that I captured it with this interval. You know, that's the whole point of a confidence interval, right? So here, I don't know what P and Q are. So, of course, I've got to use the hatted ones, right? I like that's the name of a band. Sorry. You know the hatted ones. So in a hypothesis test, we assume that this is true. I've said that a few times. We assume this is true. We're trying to show evidence then that if that was true, look what I just did. I'm so far away from you, you can't be true. Right? So if we assume that's true, that means we know what P and Q are. There's no hats on them. I'm not going to use the estimation if I'm saying that that's right. That's a very slight thing, but be careful when you do this. Don't put the hatted dudes in there. Put the P and Q in there. Let's see if you pick up on this. Let me let you guys try this problem out. All the steps are basically the same, except, so I'm still going to ask you, do you use Z-scores or nothing? What do you have to check for that? Not just then. No. For percentages, for NPQ problems, what do I check? NP, NQ, that's bigger than or equal to 5. Up to what came in strong as 5. What's that, sir? What? How do I... You commit. I can't count as 2. That's the best time. I already gave you. You guys remember this? This is a little old information now, but I don't care. I was too bored. Too lazy to create a new situation. So this is about the Occupy Wall Street movement that was alive for a little while, and then the people involved are the kind of people that normally don't continue following through on stuff. So I don't blame them too much. But we go out and we talk to people and see if they opposed it or not. The movement that was the Occupy Wall Street movement. So start to work on that bad boy. And I'll tell you this, to be real careful, are we making a claim about a mean or are we making a claim about a percentage? So in your hypotheses, what symbol should show up? Mu? Should mu show up? No, what should show up? P. I love it. Kick ass. You're making a claim about the population percentage, so the unhatted one, yes. Sounds like some kind of demon. The unhatted one. Sure, Buffy fought that one. That's your question. No. Will be faster. That doesn't come into play until. It's the first time it's out. Because this is, this is what we're going to say, okay, assuming that is the middle. So we're going to assume that is the true percentage. And we want to try to find evidence by taking a sample, and the sample so far away from that actually that can't be. So have you ever heard somebody say this doesn't happen as much as we do? They say, okay, assuming you're right, look at this. So they're saying, okay, assuming you're right, look at that, look what just happened. Assuming you're right, what's that? Maybe I'm wrong. So we're saying, assuming you're right, and we're going to try to have a little moment where we go, look what we just did. We did something really unlikely. Assuming you're right, so you must be
Yeah, we
wrong.
already did that.
I know either way.
It's just
So
196
that's our
instead of
accepted
20. I forgot.
percentage.
Yeah, so we just show that. Because when you multiply it, you're going to get the same number anyways.
But so what we're really trying to do is show that assumption is wrong.
Yeah. I don't even know we need that. One of those moments right now.
It is weird.
Again, for homework, if you do all these steps, you'll answer all the questions they ask you in the little intro paragraph, the little italicized instructions paragraph. So you can just do these steps. As you know, I'll ask you these steps on the test, so you might as well get used to those steps. I'm just going to do the first couple steps to make sure everybody's in the right track. What is your claim? Yeah, the claim is P is less than 0.25. So the minute you start doing math you better have numbers. 25% is not a number. 0.25 is the number it represents. Cool. And which one is that going to be? H1 is, yeah, and just to make sure you guys understand, very often the claim is H1, because our claim is very often, we think you're wrong, we think it's more, we think it's changed, but it's not always H1. We saw that the other day, so be careful. Don't just assume it's H1. It's H1, of course, because no equal sign. That's the real determination, right? Because of no equal sign. If you forget, there's a decent chance you'll be all right, but you know in a test I'm going to make the other situation happen. What's HO then? If you read the book and you want to put equal sign there, that's fine. I'm not going to take it personal. There's nothing wrong with that, really. So, what do I check to see if I can use z-scores? Yeah, because if that's greater than or equal to 5, that means that it's normal enough. So I want to check NP, not NP hat. I want to check NP and NQ. What's N? 916? Right? Is it? Good. My memory is right. What was it? 196 is X. It's the number of successes. N is the total number of people you actually talk to. So 916 times what? 0.25. We've already established what P is. Assuming P is 0.25, okay, P is 0.25. And what's Q?
7.
Good. So what do you get here? 229, that's bigger than 5. What do you get there? 687, that's bigger than 5. Check, check. Which means I can use z-scores. Sometimes I'm nice and I'll say Z or nothing. That's kind of a big hint that t-scores won't work. And sometimes I'm not nice. It all just depends on how I'm feeling when I make the test. Just to be honest. How are we doing so far? So it's the exact same idea. It's just when I'm dealing with NPQ, there's a different way to answer that idea. I've got to show that it's normal enough this way, not N greater than 30. I've got to show this to continue going. All right, keep going. Good. Level of significance is the area in which you have confidence. So it's always valid. Here's where people really trip themselves up. What should be true about the z-score that I put up there eventually? For sure. What should be true about it? Should be a number. No. Based on where it is, right? Why is it down there? Number one. I shouldn't make that assumption. Why is it down here? Because it's less than. I want to show that my sample is far below it. So that means my z-score should be, and I know the t-score chart is always positive. That's because it's just a freaking piece of paper. We're the humans. We know if it's positive or negative. We put it on there. There's got to be something left for us humans to do. So alpha 0.10, one tail, go all the way to the bottom of that. Which column is that going to be? The very last column is 0.10 and one tail. Really weak test. You would basically never see this test unless it was really bad if you made a mistake. Like I said earlier with the nuclear thing blowing up, you want your alarm going off at this level. So this is going to be what? Negative 1.282. I like it. So I love when people put positive and then they say if z star is less than positive 1.282. That's going to totally screw up your results. It's not the right thing. Just make sure that if it's down here, it's negative. That's all. So how can I say this in words? If z star, yeah, is less than negative 1.282, we good. Okay, we support the high. So I'll do opposite order, like somebody said earlier. Support the high, which means we can also reject the hoe. I like the way you said that. Reject the hoe. Good. All right. Yes.
Why is it less than? I don't know.
Why is this one less than?
No, because when I did z star, if z star is less than, I thought it was going to be comparing.
Where's my rejection region going to be, though? I want my sample to show up below 25%, so I want it to be down there.
Oh.
Here's the beautiful thing. H1 always sets up where the rejection region is, and that points in the direction of the rejection region.
Oh.
Right? I'm sure some of you guys have heard that the inequality points in the direction you shade. Back in algebra, if you had x less than 7, you're going to shade that way from 7. Right? Well, I'm going to keep going. That points in the direction I'm going to shade. Hey! And that's my rejection region. Cool. Sure. So hopefully you guys are maybe working on your conclusion. Who's got p hat calculated? 96 over 960. 0.214? Do I care about Q hat? Poor little Q hat. We don't care about him. Right? Aww. because we're going to use P and Q, right? We don't care about Q. N, of course, is 916. Be real careful. It's easy to put 196 there. It's going to totally screw this up. Right? Got to be careful. So Z star equals my data, 0.214, minus, become 0.214. The accepted middle, 0.25, all over square root. Yep. Of what? What goes in here? Good. P, Q, over N. Yeah, and the way you should put in your calculator actually should be that. Unless you have a radical that grows, well, it's good for you. Nah, you're all that. I'm a little jealous. I'm not sure. So you got to be real careful when you plug this whole damn thing in at once. You just got to be careful about the fact that your calculator doesn't have eyeballs. Thankfully, that would be very strange. I don't know if you donate your eyes after you die to be installed in the TI 3000 in the future, right? I'll do your problem for you. So if it doesn't have eyeballs, it doesn't know what the top is, it doesn't know what the bottom is. So you have to put parentheses around the top, and these parentheses are around there. Has anybody tried this out yet? What do you guys get for that? Negative 2.51? Sounds like we have consensus. You concur?
Negative 2.516.
Oh.
So 2.
252?
Yeah.
We have dissent. Don't concur. I like that. It's my favorite scenes from what was it? Leonardo DiCaprio, Can't Catch Me. Try to catch me. Catch me if you can. Yeah. What's my p-value for this? So here's the 1.282. That's the critical score here, right? So that had an area of 0.10 below it. What's my p-value? This is nice. It's negative. So if you look it up in the chart, you're done. 0059? Sure. Nobody else is saying anything, so I'll take it. So did we pass the test? Did we make it in here? We kicked the shit out of that test, didn't we? It said you have to make it here. We went, oh, okay. We'll go to negative 2.52. So this is do you understand what I mean? This is a very weak test. This is a weak test. But this is the kind of value I would want to put if the nuclear building would blow up otherwise, right? I want the alarm to sound the minute it's a little bit off. I'd much rather be in there checking it more often than wait until it's really far off and then I'll come check. No. I think I'll check the minute it's off a little bit. Does that make it all any sense? That's why I want to be able to control that for myself. I want to have my own personal alpha depending on how worried I am about dying in a nuclear explosion, which most of us would be very worried. Some of us would hope we develop powers, but I don't think it's going to happen. So that's my p-value. And a real quick word about this. If it had been a two-tailed test, I would just double that number to make it fair. Because alpha, if it was a two-tailed test, I would cut him in half. So to compare the p-value to alpha, I want to double it so it kind of matches back up. So if it's a two-tailed test, you just double that. So one-tailed test, it is that. Cool. Don't make too much out of that either. It's very straightforward, hopefully. What can I say here very quickly? What did we manage to do? Did we manage to do anything? We can reject the null, support the high. And which one's our claim? Oh, I said high. Which one's our claim? Good. So our claim is H1. So I want to use this language there. Keycaps. So our conclusion would be, how's it start? We have found evidence. We made it in there. That if we make it inside there, we found evidence. We have found evidence, sufficient evidence, to support the claim that
Less than 25%.
less than 25% of Americans opposed
Occupy Wall Street only.
the owls. The owls. Yeah. Owl, dude. Owl. So good to have me at the end of the day because I'm extra loopy. Okay. So we've done a stupid amount of examples now. You're all like, please, Jeff, don't have another sheet of paper. Please, to God. So I want to go back to A2 now and just fill in a couple of holes that I didn't talk about, and then we're going to head out a little bit early. Yes. I enjoy it too when I do that. I'm like, come on, Jeff. Let him out early. I don't know, man. What kind of mistake could we have made? I mean, this is a very strange question. There's a lot of mistakes we could have made here, right? But assuming we did everything right, we did every single step of this right, which we did. We were really good. What's a mistake I still could have made? Because this is stats. There's a mistake I could have made. Our conclusion said we found sufficient evidence to support the claim, which means we rejected this guy. We think this guy's wrong. So what mistake could we have made? What could actually be true that would have meant that we made a mistake? What could actually be true still? You guys can do it. So what do we think is true? After we did this, what do we believe is true? The percentage is less than 25%. What could still be true? It could be 25 or more, couldn't it? So the mistake we could have made is we said this guy was wrong. We rejected the hope. But what could have been true is that could have been true. I love that. So when I'm trying to go back, if you've done the homework at all in Section A2, you've run into Type 1 and Type 2 error questions. So everybody that's looking at me with a blank face is telling me you have not done the homework yet. So that's a quick way for me to find that out. So let me explain this to you. It sounds like it'll help you when you get there. So everybody got what they want from this here? Yeah. More than you ever wanted? Okay. So we rejected the null. So the error we could have made, the official name for the error we could have made is called a type 1 error. And the type 1 error is when you reject a true null. Does that make sense? That would be an error. The null is true and we rejected it. So think about this, though. In real life, you have no idea if you made a mistake, if you made an error. You have no idea. You can control the probability of making the error. And for this one's the easy one. The Type 2 one is a very difficult one that we're not even going to talk about. But this one, I could talk about the probability. This guy's probability is, so the probability of a Type 1 error is alpha. Bam, 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 bam. So if you want to not make that error very often, you're going to make alpha small. If you're okay with that error, if you don't want to make the other kind of error, you're going to make alpha larger. Are you guys still kind of with me? Okay, so it's sort of related to the idea of the nuclear station blowing up. Would I rather have somebody run back to check things more often, or would I rather have the station blow up? I think I'd rather have some dude hired to run back every time the alarm goes off and just check things. I think I'd rather have that. Right? You could probably tell I've never worked at a nuclear power station, because I don't think that's exactly the way it works, but hopefully. Right? Alarm's going off. I really hope that's not the way it works. I've seen Godzilla, so that's maybe it works. I like that. So that's the Type 1 error. What do you think the other error is called? Type 2. You guys have read ahead. Type 2 error. Now, here's the more interesting question. What the hell would that be? What's the other kind of error I could make? Well, what's the other thing I could have done? One thing I could do is reject the null. What's the other thing I could do? Fail to reject the null. That's basically the two situations. I know some of you guys are like, where's the support? Well, reject the null means support the high. So that's that. The minute I say reject the null, I'm also at the same time saying support the high. Because that's the same situation. Fail to reject the null means you fail to support the high. If I can't say this guy's wrong, I can't say this guy's right. Sorry, buddy. So the other error is to fail to reject a false null. So in reality, the null is false, but I fail to reject it. I fail to show that it's false. So this symbol for the probability is given the symbol beta, which is related to the idea of the power of a test, which is all kind of outside of the curriculum of Stats 1 course. But if you want to read about it, it's in that section. This one is a lot more difficult to tell the value of it. So the book attempts to show you at least one way to do it. Okay. But, yes ma'am.
I'm just confused because I feel like that type 2 is basically saying that you're supporting the HI or H1.
No. Now think about it. If I fail to say H naught is wrong, if I fail to reject the hoax, so if I can't say this guy is wrong, can I say he's right? So if he believes it's going to be heads, and he believes it's going to be tails, and I say, oh, I can't say that you're wrong, well, I can't say he's right, because it could be heads, right? I mean, you kind of see that?
Yeah, that makes sense.
Cool. All right. And then whenever that happens, somebody else is like, I thought I understood it before until you said that. I'm like, shit, I always lose people.
I like lost it now.
Damn, shit, see? All right. Well, if you had it, it'll come back. No, so what's true about HO and H1? How do they relate to each other? They're opposites. So if this guy is true, that means this guy must be false. If this guy is false, that means this guy must be true. So if I cannot say that he's wrong, let me say it like this. If I could say he was wrong, that means I could say he's right. So if I can't say he's wrong, if I fail to reject him, if I can't say he's wrong, then I can't say he's right. That's it. If I say he's wrong, he must be right. If I can't say he's wrong, I can't say he's right. Those go together. You can't escape that. Cool, I like it. You know, like, is this math class or freaking English class? What is it? I understand. All right. So, real quick example of this, using non-mathematical example first. What's in there? Let me leave that up there. So my go-to thing is this. Let's say the null. Let's say we are a medic on a battlefield, right? So a battle just happened, or is currently happening, and we're running out there, and we're checking people. What are we checking as we go to people that are laying on the ground? What are we checking?
Yeah.
We want to first check to see if they're dead or alive, right? You with me? And if they're dead, I'm going to take their stuff. I like it. You play enough video games, you're like, a pile of money showed up next to this guy. I like, take the stuff and then you do what? I'm gonna watch you. And you're like, hit him. I'm a teacher. I don't have much. So let's say my null. What do you think my null? What am I trying to show evidence against? Well, this is kind of can go either way. What do you think my null hypothesis is here? What am I going to assume? If I assume that they're dead, I'm not even going to check them out. So I'm going to say, I think that the person is alive. That's what I'm checking. And then I go up to them to check to see if that's true. Right? And so my H1 would be, the person is dead. So I like doing this example because it shows you that it doesn't necessarily have to be mathematical statements that go into these two hypotheses, right? They could be English statements that I can then connect to triage numbers or several measurements or whatever. This one's almost a little too, either they're alive or dead. They got breath? No? Move on. After you take your stuff. So what would a type 1 error mean? What's a type 1 error mean? We reject a true. So what's actually true? They're alive. So the person is alive, but we think they are. Easy pickings. Dead. Easy pickings if you still concern me. I'm going to stay this way from now on. Check my wallet. Okay. So type 1 error, the person is alive. H naught was true, but we rejected it. So we take their pulse, but everything's going on. I'm crazy. I'm like there. I don't see a pulse. Okay, I got to go on. And this guy's like, oh, shit. That's bad. What would a type 2 error be? What is actually true? What's actually true for a type 2 error? I think there. Falso, right? Sounds like another Bible verse. Stay away from the false. It's actually, I don't know. I'm not going to get too much into that. Fail to reject a false null. So what's actually true? What's actually happening? If the null is false, then the H1 is true, so they're actually dead. So the person is dead, but what do?
Treat them like they're alive.
We think they're alive. So we're trying to resuscitate them, right? But they are gone. You with me? So both situations are bad, right? Obviously making a mistake is bad. But the difference, remember, this guy is related to alpha, and this guy is related to this weird-ass beta. But what's fundamentally true is if I make this go down, this must go up. And they're not perfect. They're not like alpha plus beta is 1. Nothing that you would hope would be true. That's not true. They're kind of weirdly related. But if he does decrease, if I make my chances of this mistake go down, then obviously the chances of the other mistake has to go up. That sounds like real life. Right? So I consider which one is worse to me, and then I adjust my probabilities accordingly. So which one would be worse to you? It kind of depends on who you are, right? So say we're the medic. We're not the people on the ground. We're in control of this test. So we're adjusting alpha. So which one would be worse for the medic, do you think? And that's a rough call, ain't it? I don't know. Because what does this mean? We pass him by, but maybe we could have saved him. Right? That definitely sucks. But what's this one mean? We're wasting time. There's other people we could save, but maybe they're dying while I'm working on this person, right? Damn. This is why I would never want to work in an ER. I'd have to live with this kind of thing every day. Oh, if I would have done that, I don't know. No, there's no way. I just watch those shows, just makes me freaking things. Do you guys understand, though, the thought process? There's no way we could figure this out, really. We just have to kind of guess, or as a medic, you'd have to pick one of these to be your default, and you adjust these accordingly. This would be more of a feeling. It'd be much less mathematical. It'd be much more of a feeling, but that's still the same idea. Do you guys understand the idea? So the book, when they talk about type 1 and type 2 errors, they're not going to get very technical. They're going to be on this level. This level. They're not going to get very technical about them, because they can't, because we didn't get very technical about it, so they better not. Okay, let me see if there's something else that I forgot. I don't think so. Blah, 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 blah. Yeah, there's actually some decent little flow charts in here. Little hierarchical, like on page 383. There's a little flow chart about p-values and stuff, but you can see if they help you or not. Kind of depends. So 8.2 is really like the underpinning of all the different hypothesis tests. So in section 8.2, you will see hypothesis tests about standard deviation. But you're not going to have to run the test, because we haven't talked about that yet. This is section 8.5, and if you paid any attention to the homework sheet, that's at the very end of the semester. The reason I do that is because when you start talking about testing standard deviations, can anybody understand why that would be weird? What governs the shape of this? Versus a skinny one versus a fatter one. What governs that? The standard deviation. So if I'm making a test about this, meaning I don't know this, I'm testing something about it, I can't use this distribution because it controls that distribution. We actually have to come up with an entirely new distribution, which is why I push every section involving standard deviation. There was one in chapter 7 that we skipped that's listed later because it involves this new distribution. So I want to totally suck everything out of normal distribution I can before I introduce a brand new distribution. So that's why I push all that to the end. In case you're studying with somebody and they start talking about some weird-ass thing called chi-square, that's the other distribution, the chi-square distribution. That's going to be the last thing we talk about this semester. Yeah, and that's the dude that's used in psychology and education and that's how you test. This is how you test like more than one thing at a time. It's kind of neat. You can test like 5 different things at one time. It's neato. All right. So that's all I got for today. Well, like somebody's holding it in. Okay. Oh, quiz next Wednesday. It'll cover confidence intervals for proportions, and it will be very basic hypothesis test questions next Wednesday.